So again, we want to find the first and second derivatives. Before we do that, we need to rewrite this as a indices. So we've got x plus 2 all to the power of minus 1. I'm going to choose to use the chain rule for these. We could use the quotient rule. It gets fairly long and algebraic with lots of ones, which means you can get a bit tricked up. I'm just going to choose to use it with the chain rule. So now our first derivative is derivative of the outside, minus 1, x plus 2 to the minus 2, times the derivative of the inside, which is just 1. And I will leave space to come back and tidy that up as a fraction. And my second derivative, out the front here, so derivative of the outside is 2, lots of x plus 2 to the minus 3, times the derivative of the inside, which is 1. And I had to come back and tidy this up, so I'm going to have minus 1 all over x plus 2 squared. This one will become 2 all over x plus 2 minus 3. Oh, sorry, just 3. The negative means it's already on the bottom of the fraction. There we go. Similarly here, before I start, I'm going to rewrite this as 3 minus x to the power of minus 2. So my first derivative is going to be minus 2. 3 minus x to the minus 3, that's the outside, times the derivative of the inside, which is just minus 1. So I'm going to tidy this up just a little bit and leave myself room to come back and write it up as a fraction, because that's how my original question was given. So my second derivative now, I'm going to use this one, so I've got minus 6 times 3 minus x to the minus 4, times it by the derivative of the inside, which is minus 1. So we tidy all this up. Now I've got to come back and rewrite this as a fraction, so it's 2 all over 3 minus x cubed. And here we've got 6 all over 3 minus x to the 4th. Okay, so again, same deal. We're going to write this as an index first. And then I'm going to start with my first derivative being the derivative of the outside times the derivative of the inside, which is 5. Neaten this up, minus 15. I'm going to leave myself room to come back and write it as a fraction. The reason I'm doing that is because I want to be able to use this form as the index form to be able to use that chain rule again here. If I put it into fractions, and then that can sometimes get confusing. So I always go back and tidy it up at the end. But obviously you'll work with however you are comfortable. So for my second derivative, it's the derivative of the outside, which is 4 15ths, which is 60. Lots of 5x plus 4 to the minus 5 times that by the derivative of the inside, which is 5. So altogether I've got 300 5x plus 4 to the minus 5. And now back to tidy this up, minus 15 all over 5x plus 4 to the 4. And this one is 300 all over 5x plus 4 to the 5. Okay. Last one for this set. This becomes 2 lots of 4 minus 3x to the minus 2. So my first derivative is the derivative of the outside, which is minus 4. 4 minus 3x minus 3. Derivative of the inside, minus 3. Tidy that up. Come back later to put it into fractions. My second derivative is 3 minus 3 times 12 is minus 36. 1 off the power times the derivative of the inside, which is minus 3. Now I need to do 3 lots of 36. That's going to be 3 lots of 30 is 90, plus the 18 there is 108. That's positive. 4 minus 3x to the minus 4. Come back, write this as a fraction. And this one